Hi everyone, hope you're having a good day. Today our lesson is going to be about the reflection of light. Now, when you throw a ball at the wall, it bounces back. Similar to that, when waves encounter the wall, for example, or a boundary, they bounce back or they reflect back. Maybe partially, not all the waves reflects back. However, some light is reflected due to facing a boundary. Now, that's how actually we hear the echo. If you know how does the bat, for example, see its way through the caves? The bat actually doesn't see well, so it sends some waves, and when the waves reflects back to the bat detects the walls or the parts of the cave that the bat is encountering. So the bat can avoid hitting any wall. Now, in general, waves reflected, at least partially, as I said, because some of the waves are refracted or maybe absorbed. I'm going to tell you now what would happen to the light or to the waves anytime they encounter a boundary between two different materials. As you can see in here, the light is reflected from the flower into the man's eye. This is how we actually see. We need the light to hit the object, and the light will be reflected into our eyes in order for us to be able to see. As you can see here, a ball, when you throw it to a boundary, it will be bouncing back and forth here between the walls or the boundaries. Similarly in here when you throw a ball. Now, the bouncing back of a wave is actually defined as reflection. Now, light can be reflected, refracted, absorbed, or transmitted. And it actually depends on the surfaces that the light encounters or faces. Now, the types of surfaces we have are three types: opaque surfaces, transparent, and translucent. What is the difference between these three types and what's the meaning of each one of them? Opaque surfaces are actually surfaces that do not allow light to pass through, or at least visible light to pass through. However, transparent, let's give an example. Opaque surfaces such as the wall, the table, all these are opaque surfaces in which in these types of opaque surfaces, we don't see an image or a reflection of an image. Mirror actually is an opaque surface. However, we can see an image out of this surface. Now, let's go back to the definition. Opaque surface is a surface that does not allow light to pass through. Transparent surfaces allow light to pass through, such as clear glass. However, translucent surfaces are surfaces that allow some light to pass through. Example to that, tinted glass or the sunglasses. Actually, these are translucent, which allow some light to pass. However, not all the light will pass through. Now, when light hits a boundary between air and glass, for example, the light passes through. Some light or for example, if we have light passing from glass to air, some light can be reflected, some light can be refracted. And the definition of refraction will be taken in another lesson. And however, the reflected rays stay in the original substance. If we have reflection, reflection is the bouncing back of light in the same medium. Mirrors are simply objects that are good reflectors of waves. The light does not pass through mirror. However, we can see an image through the mirror. Now, to study reflection, we actually need to draw and to reach the law of reflection. Now, so what do we draw? We need to know how do we represent the light. We represent the light either with a wavefront, as you can see. This is all the light coming out of a source. Or this is the array of light. All these blue arrows are light rays. And here, as you can see, they spread out in all directions. Now, always light rays are perpendicular to the wavefronts. What will we be using? In the reflection of light, we will be using a light ray. We will take a single light ray in order to explain the reflection of light. As you can see, this is a wavefront. If we can take a section in here, maybe light can be represented by these are the wavefronts and these are the rays. Always the light rays are perpendicular to the wavefronts again. However, a ray is defined as an arrow that points in the direction that the light travels. As you can see, this is the source and the light is traveling in that direction. Now, here, let me tell you how do we represent the reflection. As you can see, or the bouncing back of light. Look, this is one light ray, this is the wavefront. And we will be dealing later on only with the one light ray. We will be taking one light ray, one arrow, to represent the reflection. Now, this is a light ray coming out of a light source. As you can see, this is the direction of the light ray. The light ray coming into the surface is called an incident ray. So we call this one an incident ray. And it will be reflected reflected back in the same medium, as you can see. Now, this light ray is called the reflected ray. The reflected ray. Now, how did we know that if this is the incident, this is going to be the reflected ray? Actually, we have a law that is called the law of reflection of light. What's the relation or how do we find it? Let me explain something first. Can you see this dotted line? This dotted line is called the normal line. This normal line is an imaginary line. We draw it in order to solve. So, we draw a perpendicular line. Let me show you how do we do it. This is a perpendicular, okay, 1 minute. So, undo, let me use another, in here, I'm gonna use the, okay, not the purple, I will choose a different color, maybe the blue one. Okay, here. Now, when we want to draw an incident ray, reflected ray, and the angles between them, we need to draw a normal line. The normal is actually a dashed or dotted line that is perpendicular to the surface. And we draw it at the tip of the incident ray. So I have, let me do a small sketch. So here, this is the surface. If this is the incident ray, then what do? We draw a dotted line that is perpendicular to the surface at the intersection between the incident ray and the surface. So this is the surface. This is the incident ray. I will refer to it with a capital I. Now, how will it be reflected? It will bounce back. However, the rule says that the angle of incident, and where is the angle of incident? This is the angle of incident, which is the angle in here that the incident ray makes with the normal. As you can see, let me change in here. This is actually the angle of incident, which is the angle that the incident light ray makes with the normal. Pay attention, not with the surface, with the normal. The normal is the dotted line that you drew that is perpendicular to the surface of the mirror or any surface we have in here. Now, how will it be reflected? It will be reflected here in that direction. And this is the reflected ray. This is the reflected ray. And the angle in here is called theta r. Maybe my drawing isn't that accurate because I will tell you why. This is the reflected angle. Now, the rule states, or the law of reflection states that the angle of incident is equal to the angle of reflection. Now, which means, pay attention, the angle that the incident ray makes with the normal is equal to the angle the reflected ray makes with the normal. Here. So this is called the incident ray. This is called the incoming ray is called incident. The outgoing ray is called the reflected ray. And the angle between incident and normal is called the angle of incidence. And the angle that is between the reflected and the normal is called the reflected angle. Now, and the rule, the law of reflection states that it's very simple. The relation between them is simple. Theta I is equal to theta R. As you can see, they are equal, and this is called the law of reflection here. So this is simply the law of reflection that we have. Let's check out the definitions we have in here. So the normal is the line that is perpendicular to the surface. Okay, the incident ray is the incoming ray hitting the surface of the mirror or the surface in here. The reflected ray is the ray leaving the surface. The angle of incidence is the angle the incident ray makes with the normal. Pay attention, it's the angle that the incident ray makes with the normal, not with the surface. And then we have the reflected angle in here, which is the angle that the reflected ray makes with the normal, as you can see, and the relation says that they are equal. We can conclude some other things. We can say that here, that angle in here, theta 1, and this is theta 2. They are equal. But these aren't the angle of incidence and angle of reflection. These are the angle of incidence and angle of reflection. These are the angles that the incident and the reflected ray makes with the surface. Why is it important? It's important when you read the question. Pay attention. So when I tell you that, for example, focus please. When the angle, the light, the incident ray makes with the surface is 60 degrees. How much is the incident angle? Again, if the angle the incident ray makes with the surface is 60 degrees. What is the angle of incidence? It's actually this amount in here, which is 90 minus 60, which is 30. So you have to pay attention to what does the sentence have. So we said that the law of reflection states that the angle of incident is equal to the angle of reflection, or the incidence angle is equal to the reflected angle, and these angles are the angles that the incident ray and the reflected ray makes with the normal, not with the surface. Let's look how does it happen. So we said that the angle of incidence is equal to the angle of reflection, and this is the law of reflection. Look at what's happening there. So I have a surface, incident angle, this is reflected angle, this is the normal that is perpendicular to the surface, and we say that the angle of incidence is equal to the angle of reflection. Now, I have a question for you. If the incident ray is on the normal, then what is the incident angle and the reflected angle? Again, I will ask the question and then I will draw it. If the incident ray is on the normal, how will the light ray be reflected? Let's draw it. So, in here, okay. So, I have a surface in here, as you can see. Oh my gosh, it is, let me check if I can have a line. Okay. Okay. So, what's happening? Okay. This is a surface. This is how we represent the surface actually of a mirror, for example. We said that the incident ray is on the normal. So let's draw the normal here, the dotted perpendicular line. Here, dotted perpendicular line. They said that the angle, the incident ray is on the normal. So this is the normal. It is on the normal line, and it is perpendicular to the surface. How will it be reflected, and how much is theta I and theta R? Now, as you can see, the incident ray is actually on the normal. So the angle of incident, the definition of angle of incident is actually that the angle the incident ray makes with the normal. Since the incident is on the normal, then the incident angle is 0 degrees. And the law of reflection says that theta I equals to theta R. So theta I should be equal to theta R. So I would say both are 0 degrees. So the incident ray will be reflected on itself. Here is the reflected ray. It will be reflected on itself. So when the incident ray is on the normal, the incident angle is 0, the reflected angle is 0, and the incident angle and reflected are on the same path, or we say that the incident ray is reflected on itself. Here, as you can see. Now, let's solve this example. If a light ray strikes a flat mirror at an angle of 33 degrees from the normal. Let's draw the figure. It's better for us to imagine it, but like a quick sketch. Sorry, I'm going to take this one. So I have in here a surface, and I have a light ray that strikes a flat mirror at an angle of 30 degrees. I'm not using a protractor, it's just a small sketch. So it makes an angle of 33 from the normal. Sorry, let me be more accurate. So here. Okay, 33 from the normal. So here it is. And this is the normal, which has a 90 degrees with the surface. This angle is 33 degrees, which is the incident angle. Correct? This is what the question says. 33 degrees from the normal. Now, the reflected ray will be 27 degrees from the mirror, 90, 33 from the normal, 57 from the normal. Actually, let's reflect it. So it will be reflected this way. This is the incident. This is the reflected. And this angle should be equal to that one, which is 33 degrees from the normal. So it's 33 degrees from the normal. I need to ask you a question. What's the angle that the reflected ray makes with the surface? What do you think with the surface of the mirror? So this is the mirror. The reflected ray makes with the surface is actually this one, which is basically 90, because this is a 90 degrees, the normal from the surface, 90 minus 33, which is equal to 57 degrees. Pay attention. So 57 can be an answer. We say 57 degrees from the surface, from the mirror's surface. So, but it's not. They said 57 degrees from the normal. Now it's 57 from the surface of the mirror, or 33 from the normal. Clear? How much is theta incident? 33. How much is theta reflected? It's also 33 degrees. Now, we have two types of reflection depending on the type of the opaque surface we have. We can have smooth surfaces, and we can have rough surfaces. Now, in both cases, you have to know, in smooth surfaces, in rough surfaces, all light rays obey the law of reflection, meaning each light ray will be reflected with or according to the law of reflection, in which theta incident is equal to the theta reflected. However, if we have a smooth surface, such as a mirror, or maybe if you have the water surface, okay, it is shiny, it reflects light, in all the light will be reflected in the same direction, meaning look at the incident rays, they are parallel, they would be reflected parallel because the surface is very smooth. Each of the light ray is following the law of reflection, meaning if I want to draw a small sketch to show you in here, look, if I do the normal in here, and the normal in here, and the normal in here, in all cases I will have theta incident equal to theta reflected. Theta incident is equal to theta reflected. Okay? So when all the light ray are reflected parallel to each other, then we say that the reflection is specular and we can actually see an image, a clear image. However, if we have a rough surface, like the wall maybe, the towel, the book surface, the table surface, it's actually a rough surface, if you look into it like on a microscopic level, it is a rough surface. As you can see, all light ray is hitting the rough surface. All light rays are parallel to each other here, incident rays, and they will be reflected in different directions, not parallel to each other. That's why we don't see an image. However, each one of the light rays follow the law of reflection. However, the normal in each case is different depending on the surface. So again, here, this is the normal. So theta I equals to theta R. But in here, we can say that the normal is now in that direction. So, and theta incident is equal to theta reflected. However, the normals aren't parallel to each other. Look in here. The normals are parallel to each other. What you need to know is that in both cases, all light rays follow the law of reflection. Theta incident equal to theta reflected. However, in specular reflection, the surface is very smooth and all light rays will be reflected in parallel manner, so we are able to see an image, a clear image. However, in the diffuse reflection, the light rays will be reflected in a diffused manner. They will be scattered or spread apart. And however, each one of them follow the law of reflection. However, we cannot see a clear image, or we don't see an image at all. And this is called diffuse reflection. This is specular reflection. We see an image, we don't see an image. This is the difference between specular and smooth reflection. Now, we have types. We will go into mirrors. We have types of mirrors, and the mirrors are either flat mirrors, which we call plane mirrors, or we can have curved mirrors, in which we have two types, and I will explain this in another lesson. So we have flat mirrors, plane mirrors, and we have curved mirrors. Let's talk about the flat mirrors now. The flat mirrors are the mirrors we use in our life, the one you see yourself in. So, as you can see, this is a flower, and you can see reflection of it. We can see the image of the flower on the other side. Now, you need to know something. This is the mirror. We need to have light to be reflected back to our eyes in order to see objects or see the image inside the mirror. Now, what can you say about the image or your image in the mirror? Now, we say that my image will be the same size as mine. It's my image, it has the same size, same height, same width, same everything. If I'm standing upright, I will see my image upright. If I'm 1 meter away from the mirror, my image would be inside the mirror with 1 meter's distance away. If I'm like 3 meters away, I will see my image even deep inside the mirror, like 3 meters inside the mirror. Same height, same distance, everything. However, we say that whatever you see inside the mirror is called virtual. It's an image. It's not an actual object. I'm the object, and my image inside, it's an image of me. It's not actually me, and it is in a virtual side. It is not in the real side. Now, so we say that the image that I see of a plane mirror is actually a virtual image, which means it's not a real object. It's virtual. It's inside the mirror. Whatever you see inside the mirror is a virtual thing. This is an inside, so virtual part. And we say the image has the same size and same height, and it is of same distance between the distance between the object and the mirror would be the same as the distance between the image and the mirror. However, we can say that the image of a plane mirror is actually laterally inverted, meaning you would see the left right and the right is left. And that is the only difference in the image coming out of a plane mirror. Now, so the image is actually upright. If the object is upright, the image has the same size. This is the image, same size of the object. It is at the same distance from the mirror here. And pay attention to this part. This is the distance between the object. So This is the distance between the object and the mirror. And this is the distance between the image and the mirror. Both are equal. We refer to the distance of object as DO, and we refer to the distance of image as DI. So DI, distance of image, DO, distance of object. You need to know that since it's in the virtual, which is not real side, the distance of the image has to be negative. And now we have the image is actually virtual, which is not real, because the light rays do not actually pass through. They don't pass through. Now, we have how actually do we draw, as you can see here, this is how we draw the image of an object. Now we have the mirror equation, and the magnification, is it here? No. I will get to the mirror equation in a bit. However, so we can say that the image distance in here, the image distance, as you can see, is equal to the object distance. However, it's a negative one. So the distance of image is equal to the negative of distance of object. If this is 2 centimeters, this is going to be negative 2 centimeters. If this is 5 centimeters, this is negative 5 centimeters. The negative means that the image is behind or inside the mirror. It is virtual, not real only. It means that it's not real. The image height, we refer to the height of the object as HO. We refer to the height, let me draw it. So we refer to the height of the object as HO, and we refer to the height of the image as HI. And they are equal here, as you can see. Height of image is equal to height of object. Let's solve a question related to the image. Now, of a plane mirror. Okay? A girl stands 4 meters in front of a plane mirror. Her little brother is 2.8 meters in front of her, directly between her and the mirror. What is the distance from the boy to his sister's image? It's confusing, actually. So I need to draw in order for me to understand what do they want or what's given. So a girl stands 4 meters in front of a plane mirror. First of all, I would draw a plane mirror. Okay? And I say that this is the girl in here. This is the girl. Okay? And she is 4 meters in front of the plane mirror. So 4 meters away. Okay? Now, they said her little brother is 2.8 meters in front of her. Let's change the color. This is the boy in here, and he's 2.8 meters in front of her. Here is her brother, little brother, so I drew him like with a smaller arrow. This is the brother. And he is 2.8 in front of her. In front of her, directly between her and the mirror. So he is 2.8 meters away from her, in front of her. Now, what is the distance from the boy to his sister's image? Let's draw the image of the boy and his sister so we can find out how far is he from the sister image. Let's draw the images of both of them. I'm going to have a purple color. So, can I conclude, however, how much is the brother from the mirror? If this is all 4 meters and this is 2.8, then this one is going to be 4 minus 2.8, which is here. The purple is the start of solution. It's going to be 1.2 because meters, because 1.2 plus 2.8 is 4 meters. Now, if I want to draw the brother, I'm going to draw him in here. This is the bro image. So we do accent. Then we have the girl in here. Also, this is the image. I say that the girl is 4 meters away from the mirror. It has to be almost accurate. And the brother is 1.2 meters away from the mirror, and he is 2.8 meters okay, from his sister's image. Now, they asked, what is the distance from the boy to his sister image? Yep, so let me change the color also. I'm gonna pick like a green. Okay, in here. So they said, what is the distance from the boy to his sister's image? From the boy to his sister's image. Here is the image. Now, we need to know all this distance. So, from the brother to the mirror, it's 1.2. From the mirror to the girl is 4. So, it's going to be 1.2 plus 4, which is 5.2 meters. And this is what they are asking about. The boy is 5.2 meters away from his sister's image, as you can see. I hope you understood it. We can ask other questions. We can say, how far is the girl from her image? Let's write down this one. The girl from her image. The girl is 4 meters away from the mirror, and her image is 4 meters away from the image. So 4 and 4. It's going to be 8 meters. The girl from her image, it's 8 meters. This is a practice. Now, okay, let me show you a simulation to see how we can see the image or we can draw it. Let's check out how do we, okay, again, let's look. We actually, how do we draw the image of an object? This is the mirror, as you can see. This is the object, it's a pencil. And this is the image of the pencil, okay, in the virtual, not real side. Okay, how do we draw it? We actually can take 2 arrows and reflect them according to the law of reflection in here. So, okay, we can take only 2. They took 3. We take 1 arrow, as you can see in here, 1 light ray and reflect it. Okay, then we take another, for example, this one, and reflected. Then what do? We intersect the reflected rays. As you can see, the reflected rays are going in different directions, and they will never meet in the real life, in the real side. However, the reflected ray extension will meet in the virtual side. So we take, this is the reflected, we take a dotted part and a dotted part from the other reflected ray, and the crossing of between them, when they intersect, is actually the tip of the pencil. We draw the pencil in here. This is the distance of object in here is equal to the distance of image, as you can see. Okay, now this is how we draw in here. Let's look at it again. It's very fast, actually. I hope I can slow it down. If we have not a pencil, for example, an arrow. Okay, let me close the. Okay, or let me take the principle. As you can see in here, we took only like a light ray that is reflected on itself and another light ray that is reflected with certain angles. The crossing between them gives me the image. Distance of image is equal to negative distance of object, and the height is the same, and so on. We can actually move, as you can see, whenever the object is close to the mirror, the image is also closer to the mirror. I hope you understood the law of reflection, the types, the plane mirror type, and the types of reflection, which are specular and diffuse. Please solve the following question to check your understanding. Thank you for listening.